In this section, we're going to cover fine-tuning and how to use it. And just to preface, this is a completely optional section and requires some programming expertise. If you do not have programming expertise, you can still follow along. However, you might be more comfortable skipping over this section entirely and moving on to the next section. So, what is fine-tuning and how are we going to use it? So, fine-tuning at a high level is cheaper and faster than training your own LLM. Provided LLMs or foundational models are pre-trained on large amounts of data, fine-tuning is an additional step on top of the the foundational LLMs, and it adjusts the final weights based on your specific use case. This is really good for use cases that might not be commonly trained, such as customer support, translating languages that aren't publicly available, or operating on data that isn't available on the public internet. And it can make a general LLM like GPT-3.5 much better at a specific use case, like, for example, writing a blog in a voice that is unique to you, or use new information that isn't publicly available. So a visual of this is a pre-trained LLM, which is computationally expensive, uses a large unlabeled corpus, which is a training set, and then a fine-tuned version is built on top of the pre-trained version and uses a smaller labeled corpus, which is the data set that you're providing. So how do you fine-tune an AI model? It's a very straightforward process that includes steps such as choosing a pre-trained model like GPT-3 or GPT-3.5, which are available by OpenAI. They're the most popular and the easiest to use because they provide a easy API that you can interface with. And you put together a data set that is specific to your task. This is called your fine-tuning set. And then you begin training the AI model with the new fine-tuning set. And you do this for multiple iterations until you get to the desired output consistently from the newly trained model. Fine-tuning with the OpenAI API is what we're going to cover in this section of the course. And at a high level, OpenAI provides APIs for fine-tuning a GPT 3.5 model. This requires some experience with programming to call the API and begin the fine-tuning process. Fine-tuning is near instant with a small amount of data and takes gradually longer as you increase the size of the sample set. And you can use these fine-tuning LLMs interchangeably with regular LLMs in the OpenAI platform. These models, however, are unique to the OpenAI platform since they rely on the general GPT 3.5 model, which is not publicly available outside of their platform. And you would need to know how to use the shell commands, and that makes this part of the course a lot easier. Like I said, this section is optional. If you do not have programming experience, you might be more comfortable skipping to the next section. The use cases of fine-tuned AI are the follows. You can use it for many things, and this is not a complete set of all the things you can use it for. Some things are customer support tasks, like responding to requests from internal customer service databases. These documents might not be publicly available, and this is why it's a good choice for fine-tuning. You can also update the responses from being more general to being something more specific. For example, you can inform the AI to be kinder or be more focused on customer service, and these are things that the general AI model might not be good for. You can do translation to a new language that you might make up or is not publicly available, and you can generate content tasks such as writing in a specific style. These are extremely powerful because there is a lot of optionality with this. For example, if you wanted to create a virtual world and you created a custom language, you can feed an AI model this custom language, and you can train personalities and then create characters out of these using some of these use cases like translation, generated content. That's just one example. There's a ton of examples that you can use fine-tuning APIs and a fine-tuned AI model for. And it's important to cover when is not a good time to fine-tune. Fine-tuning covers a lot of use cases. However, it's not perfect for every use case. Some of these use cases that it's not good for might be there's a small data set. Larger data sets generally provide better results for the fine-tuning models. So smaller data sets don't give it enough data to accurately update the weights, and then you'll get a below par fine-tuned model. Another time when it's not good to use a fine-tuned model is when the data changes quickly. Because you're retraining the AI model, this adds up to the costs and makes fine-tuning a model much more expensive. And also you have to do it more often, since as data gets updated, you will need to update your model. And then simpler methods might solve the problem that a fine-tuned model might be overkill. So you have to be conscious and understand your problem. So sometimes fine-tuning is not the right approach. Sometimes using a general LLM model might be the right approach. So these cover some of the times when fine-tuning is not good. So in the next few lectures, we're going to cover how to get an OpenAI API key, and we're going to go through the process of fine-tuning a GPT 3.5 model on the OpenAI platform. Now we're going to go over creating an account on OpenAI, and we're going to go over how to do that and generate an API key for your application. So first step, you need to go to openai.com, and there should be a sign up button on the top right if you haven't already signed up. If you have signed up, just click login instead. And then once you're on this page, choose any of the available options such as Google, Microsoft, or Apple, or just enter your email and a password and create an account. Once you create an account, you'll be presented with a page like this, and you'll have options with ChatGPT, DALL-E, or API. Click API on this page. Once you click API, now you're in a developer console where you have some examples on how to build an application, as well as documentation, reference, playground, and example. And go to the very top and click Personal, followed by View API Keys. Once you're on this page, you should have no API keys already set. I have a few already made, but I'm going to create a new one for the purposes of this video. So just click Create Secret Key down here, and you'll be presented with a UI for choosing a nickname for your key. You can enter any nickname you want, just make it memorable to reference later. And then once you create a nickname, you'll be presented with a secret key. Make sure you don't share this with anybody, because with this key, anybody can access your account and make requests on behalf of it and drive up your bill. So if you expose this key publicly, other people can use your account to drive up your bill to increase the amount they have to pay per month. So make sure you make a copy of this, make a note of this, and then don't share it with anybody. You'll only be able to see it once. If you don't have access to this, you can make another secret key and delete the previous one. And that's it. With that secret key, you're ready to move on to the next section. Now that you have your secret key, it's time to set up your environment. And we're going to be working with Python in this course, so we need to make sure that Python is installed. And if you do not want to install Python on your program, on your operating system, then there is an option for using Python without any installation completely in the web. I'll go over the sections on installing it on your operating system. Otherwise, in following that, I'll give you an option of running it completely in the browser. So make sure you have Python installed. There are 3 different guides, one for installing on Mac, one for installing on Windows, and last one for installing on Linux. So the first one is a free guide by dataquest.io for installing Python on Mac. Just click through the link, which I will attach in a subsequent resource on the course that you can use to install Python on your Mac computer. You can also install it on Windows using a guide provided by Microsoft, and installing Python on Linux by following a guide by python-guide.org. So once you have Python, you should be able to type Python into the terminal and enter a virtual shell. If you do that, then you know that you have Python installed correctly. If you don't want to install Python, you can also use Replit, which is an integrated developer experience. It runs completely on your browser, so you don't have to install anything onto your computer. So to get started, just go to replit.com and then make an account. If you go to the right website, you should see something like this. And the sign up button is in the top right corner. If you don't have an account, click sign up. If you already do, click log in. Create a new Replit. Once you have an account, you should be greeted with a page like this. And there is a top left button called create Replit. So just click that, and you'll be presented with a screen that gives you a bunch of options for templates. Make sure you choose the Python template, because if you choose any other template, it will not be set up correctly and you won't be able to follow this course. So make sure you choose Python. That way you have the integrated developer experience for Python, and you can follow all the commands that you have in this course that we are going to go through. So If you set it up correctly, you should be presented with a screen that looks like this. You have the Python logo on the top left, which means that this is a Python project. You have a main.py file that lets you write code, and you have a console, which is your virtual Python console, as well as a shell, which is your terminal. If you have this page, then congrats, you have Python set up, and you can run Python programs in your browser without doing anything. And now we are ready to move on to the next section. With Python installed, now we need to install the OpenAI library. In your terminal, we need to make sure that pip is installed, which is the preferred installation program, or also known as the Python package manager. There is installation for all operating systems following this guide. Alternatively, you can run and install it by running this command in your terminal, curl with the installation URL, pipe to Python. This should work on macOS, Linux, as well as Windows if you have Python already installed. If you follow the replit guide, then it will already be installed for you. So to test this, go into your terminal and type pip. If a screen that looks like this pops up, then that means that pip is installed correctly. It should have all the commands as well as some general options. You can get to this in replit by clicking on the shell button on the right-hand side, not console. Console is a Python interpreter, which means you can run Python programs and Python commands there. However, shell is your terminal, so pip is installed on the terminal, not on Python. So double check that before you run it to make sure that you're on the right tab. And once you have pip installed, just make sure you run this program in your terminal to install OpenAI. So pip install -- upgrade. That's 2 dashes, not 1. OpenAI, one word. If you install pip as pip3, you can type pip3 install and the rest of the command, same as normal, to install OpenAI. So once this command runs successfully, you have the OpenAI library installed, and we're ready to move to the next section. Now let's go over pricing and setting usage limits for the OpenAI API. So why set usage limits? First of all, we don't want to be surprised with a really big bill. The OpenAI API is charged per use, and the usage can grow extremely quickly, especially if your application goes viral, which is always a risk with the internet and releasing applications online. If you suddenly get a large spike in usage, you might run out of usage or get presented with a large bill, which you might not be ready to pay, especially if you were giving your application away for free. This is definitely a risk that you should look forward to or look out for when you're using the OpenAI API. So the current pricing as of July 23rd, 2023 is currently looking at 2 different models. We have GPT-4, which is a more advanced model, however, is also more expensive. And then GPT 3.5 Turbo, which is the one we're going to focus on in this class, slightly less expensive. And there are 2 different pricings, one for input and one for output. So one thing to note here is that 1 token is equal to 1 word. A token, in this case, is done as 1 single word in the input, and pricing is priced by bundles of 1,000 tokens. So, for example, if we have 10,000 words in and out, which is 10,000 words in and 10,000 words out, we have a total cost of 3.5 cents for the 4K context. For 100K words in and out, it costs 35 cents. And for 1,000,000 words in and out, it costs $3.5. This is looking at the GPT 3.5 Turbo at 4K context. So now that we have some basic idea of the pricing, let's go ahead and set usage limits. So we can do this by going to the OpenAI developer dashboard and then clicking first on our profile and then clicking View API Keys. From here, you will be presented with all your API keys as well as the symbol and label that you've given to them. And then go to the left-hand side and click Billing. And then once you click Billing, you should be presented with a screen like this where you can set your usage limits. So click on Usage Limits and you'll be presented with a page like this. There's 3 major important things on this page, and then 1 thing that lets you know how much usage you are going through right now. So approved usage limit is the maximum amount of money that you can spend on the OpenAI API per month. This is set by the OpenAI team, and you can request to actually increase this if your application is getting a lot of usage and you need more. one other thing is a hard limit. This is your custom set limit to how much money you can spend on the OpenAI API every month. I set this as $50 because I think that's reasonable and that actually gets us a lot of usage. And there is another field called a soft limit, which is a lighter limit that once hit will email you that you've reached that limit and ask you whether to reduce your usage or increase the soft limit so you don't get emailed again. So I set $10 because this seems reasonable. This is still a lot of requests. So once it hits that soft limit, I'll know that I hit the soft limit and then I can go ahead and adjust that or maybe reevaluate my program to see if I can reduce usage somehow. So with that, we set the pricing and usage limits. Let's go on to the next section. Now we're going to go over a high-level overview of the OpenAI API. And this is a preface before we start working with the API in our trial and example classes. So the AI API options for text generation include two endpoints. One that's chat completion, which takes context into account, which we'll go over later in this lecture and following lectures. And then another one that is text completion, which is a zero-shot prompting technique, which, given a prompt, gets a response from the LLM. And other API features that aren't covered are image generation, audio transcription, file parsing for file fine-tuning, embedding, and content moderation. All of these are different endpoints that are provided by OpenAI's API, whereas image generation lets you generate image based on a prompt. Audio transcription allows you to provide an audio file and then get a transcription of it. File parsing allows you to fine-tune model responses based on files such as a PDF or an Excel sheet. Embedding converts words, a prompt into a format that you can use for your own machine learning. And content moderation allows you to manage content on a forum and is derived from classification that lets you check whether a piece of content adheres or doesn't adhere to OpenAI's content policy. So what can you do with it? You can summarize, you can create chat AIs, you can do translation, you can do data extraction or classification, categorization, and sentiment analysis, which I consider all in the same category, and many more things as you want to try many things that you could experiment with and see what the AI ends up coming up with. So to use the OpenAI API, the easiest way to do so is using the Python library, which we already set up in the setting up your environment section of this class. So you can install it using pip, and you can learn more about it using the GitHub link, which I'll attach to this lecture. And let's go over the chat completion API. This is the first one, and it uses the B1 chat completion endpoint and provided OpenAI API key and parameters such as the model GPT-3.5 Turbo, which is the one that we're using, and then a series of messages which provides context. Will provide a response. So in this case, let's decipher this parameters. We provide two messages for the system. You are a helpful assistant. So we're telling the system that it's a helpful assistant. And then one from the user, which says, hello. The response from here is the assistant will say, hello there. How may I assist you today? And this is a case of the returning value of the chat. Given the context, they read that the context in the first message is you are a helpful assistant. The user said hello. The assistant will respond with something that adheres to both of those contexts, and this is an example of few-shot prompting, which we'll cover later in this class. So let's go more in depth in the parameters. There's three major parameters that we're going to be using repeatedly in this class, and this is the model, which is a model that is interchangeable, and the one that is going to be generating the text. In this case, we're using GPT 3.5 Turbo. Another one that we can use for chat for completion is DaVinci 3, DaVinci 2, and Ada. There is max tokens, which is the maximum number of words per response. This is important to know because there are two ways that a response can terminate. Either it will hit an end sentence, which is something that is found via the LLM and is set during training time. So for example, an end sentence could be a period, or it could just be at end of paragraph and there's nothing else after that. If it hits one of these, then the system will respond with something. Otherwise, if the number of tokens exceeds the maximum number of tokens, it will quit and exit at the maximum number of tokens. So if you have a response that should be 105 words, but you set a max tokens of 100, then it will quit at 100 words, no matter what it is doing in the middle of a response. So you want to set your max tokens comfortably ahead of the number of tokens you're expecting from your LLM. The temperature is another word for the creativity of the LLM, and it can be a number from 0 to 2, and it changes the variance of response. So the temperature, as seen in the transformer section of this class, when the LLM tries to find the next best word, it will attempt to do a probabilistic function if there are multiple words that could come after the series of tokens. And based on the temperature, it actually changes the variation, and it might pick something that is actually less probable of being used rather than something that's more probable. And then, in a way, this is sort of changing the creativity, because now you're hearing something that you don't expect rather than something that you are 100% expecting. So these are the main parameters, and you can use these to change the response based on the input of the API call to the LLM. So try it yourself. You can take this command and paste into your terminal. Just replace the secret key with the secret key that you made in one of the earlier lesson of creating your account, and then paste that command, which does a curl request to B1 chat completion with your secret key and parameters of the model, GPT 3.5 Turbo, and then the messages, "You're a helpful developer, hello," and then the response should be the assistant telling you a response based on the previous context. Now that once we did that, let's go to sample completion, which is a second API we're going to be using in this course, which is V1/completions. And this is to complete a prompt. So in this case, we're using the model TextDaVinci 3, which is one of the prompts that's provided by OpenAI. And we're using the prompt, say this is a test with the maximum number of tokens, 7. Can you tell me what the maximum number of tokens does? And let's say that there's a response that should be 9 words. What would happen with the response with the maximum number of tokens, 7? If you said that it would cut off at 7 words, you're 100% correct. And a sample response from this prompt might be, this is indeed a test. And this is correct because it has less tokens than the maximum number of tokens of 7. And just a note, DaVinci 3 is a variation of the models that OpenAI provides. And a complete list of models can be found in this link, which I'll attach in the lesson for this lecture. And you can try yourself. Here's another command that you can use in your terminal. Just replace the secret key with the secret key that you generated, and then run this curl command, which does a completion based on the prompt is there cake at the end. And when you get this, make sure you add it to the FAQ or send me a message. Let me know what you got. And this is an example of using the B1 completions API. Now that we've had a high-level overview of what we can do with the OpenAI API, let's move on to the next section of actually working with it. I want to issue an update on the OpenAI API. Since the course was created, there have been a series of deprecations. One in particular is the completions API. Everything now is moving to chat completions, and since the course is created, a lot of the underlying course content is built on the completions API. So a lot of the models that are currently supported in the OpenAI API are no longer supporting this API. The only one that is supporting this is the GPT 3.5 Turbo Instruct. So if you decide to continue using this completions API, you will need to use the GPT 3.5 Turbo Instruct model. DaVinci and GPT 3.5 Turbo are, DaVinci is deprecated and GPT 3.5 Turbo is a chat-only model. So make sure you use this model to make your completion calls. Thank you. That's all for this video. Now let's go over our first example of using the OpenAI API. And we're going to use an example of translating an article with the API. So this is an example of zero-shot prompting. And in zero-shot prompting, we're relying on an LLM's existing understanding of the world to get an answer from the single prompt. And it is zero-shot prompting because we aren't providing any examples. On the converse side, when we provide examples, this is an example of few-shot prompting, where we provide what the LLM should output based on the input, and then the LLM will learn from that and frame the output based on those examples. So in this example, we're only going to be providing a prompt and then expecting an answer. Thereby, we're only relying on the existing knowledge that the LLM has during training to get the answer that we're looking for. So a basic prompt example in this case is, quote, please translate this article to first placeholder, second placeholder, and third placeholder words, where we can replace the first placeholder with the language we're translating to, the second placeholder with an article link or text we provide, and the third placeholder with the number of words we want the response to print. An example query might look like, please translate this article to Hindi with this link from the Wall Street Journal in 100 words. So a response might look like this. And one thing that's important to know is that the response could be longer or shorter than the number of words provided in the prompt. This is because it looks for an end character rather than doing the exact number of words. A way to modify this is to change the max number of tokens, because remember, the LLM will never print more than the maximum number of tokens. However, it could end before the number of words that we specified in the prompt is returned. So 2 things to consider are the performance and efficiency considerations. We'll go over the performance considerations first. As a general rule of thumb, the longer the response is, the less accurate it may be. And a prompt is just a general guideline. The LLM response may stop early or print more words than expected. This is because it generally looks for a stop word or stops at the maximum number of tokens specified. If the length is longer than the max tokens, it will never print more than the max tokens. And a few efficiency considerations. As a general rule of thumb, the fewer words you ask for the LLM to provide, the faster the response will be. And this also decreases the cost of the query. Because remember, we are paying based on the number of words inputted and the number of words outputted. So the fewer amount of words inputted and the fewer number of words outputted means we have a smaller bill to deal with. So now let's go to a live example of running this translation function. Very similarly to the previous section, now we're going to go over summarizing an article with OpenAI API. So this is another example of zero-shot prompting, where, as we previously learned, we are relying on the LLM's existing understanding of the world to get an answer for a single prompt. And it's zero-shot prompting because we don't provide any examples. We're just relying on what the LLM already knows. So in this case, it is a slight variation on the previous prompt, and we can use this basic prompt example. Please summarize this article with placeholder and placeholder words. We'll replace the first placeholder with an article link or text that we provide, and the second placeholder with the number of words we want the response to print. An example query might look like this. Please summarize this article with the Wall Street Journal article we used in the previous lesson in 100 words. And a response might look like this. Barbenheimer, which is a movie that just came out 2 days ago, is a movie set to dominate the box office this weekend, with box office analysts predicting it could earn 45 million, yada, yada, yada. And this is a total of 1 of 5 words. So this is an example of how the number of words you specify in the prompt might not actually be the number of words that's returned, but it looks for stop words. And in this case, the number of words is actually set by the max tokens. So if you set the max tokens to 100 words, this would actually cut off at it, and it would be a half-complete response. However, we set the max tokens to 300. Therefore, we actually got the full response, and it attempted to fit it as closely as possible with the number of words that we requested. This shows some sort of higher level reasoning that it's able to understand that 100 words in the response means that it should stop around 100. So some performance considerations. As a general rule of thumb, the more recent the article, the less accurate it will be to summarize, because OpenAI's LLM stopped its training at the end of 2021. The prompt is just a general guideline, and the LLM response might stop early or print more words than expected, because they're looking at the maximum number of tokens as the maximum number of words it can return. And if the length is longer than the max tokens, it'll never print more than the max tokens. This has been covered in the previous section, so this is just a refresher for this lesson. Efficiency concerns. As a general rule of thumb, as mentioned in the previous section, the fewer words means you'll be able to get a faster response. It'll actually cost less because you're being billed based on the number of tokens. And if you use less tokens in and less tokens out, then you'll be able to get a smaller response and a cheaper response. So with that, let's go to our live example. If you've been following the OpenAI API development guide and you've been running into an error that one of the API endpoints is no longer supported, follow this video to learn how to upgrade your OpenAI API project to the new version. So if you are greeted with an error like this that says that you try to access an old API version that's no longer supported, and they give a set of commands they can run as well as guides, we can go ahead and use these instructions to upgrade our API development version. So they want us to run OpenAI Migrate, which is an automated tool that searches through all your Python files and tries to find any OpenAI instances with the old code and migrates it to the new one. So this entire process is automated. It will automatically try to delete the old code and add the new one. So let's go ahead and just run this. I already had it installed and I'm only upgrading one file called exemplars. You can see here that it removed this old OpenAI code, import code, and added the new one. And then it also changed the completion call to use the client.completions.create. And then after running this, we can go to the file and you can see that this is updated with the new API, signature. So it's not perfect. There are some small issues like the imports might be out of order. However, overall, this will get the job done and automatically migrate all of your API versions. So if you need to run this, all you have to do is type OpenAI migrate and it'll automatically migrate it, assuming there are no errors, and save the updated code in your existing file. So that's it. Let's move on to the next section. Now let's go over chat completion and the API by creating a chatbot with the OpenAI API. So this is the first time that context is starting to play a factor into our prompting, and context is important. It's different from the previous examples of zero-shot prompting because we now take this context into an account, and context is previous chat conversations that provides guidance for the future output of the LLM. So as an example, given this chat sequence between a system and a user, now the assistant will print out something that's based on the previous context. So the system settings are saying, you're a helpful assistant built to provide guidance on doing chores. You're trained on white-collar jobs like scheduling appointments, data entry, and making reservations. This is the system prompting the LLM and setting it up in a way that primes it to provide responses based on the existing settings passed in. The user then sends a prompt, I need to make an appointment with Bob Saget tomorrow at 3 p.m. And now the assistant is waiting to provide a response. This is all one giant prompt. So the response takes into account the previous messages to build its new response. To translate this into code, we might have a series of dictionaries similar to this. The first one is a role of a system that has the content of the first message. The second one is a role of system that's the concept of the second message. The third one is a role of the user, which states what they need the LLM to do. And this is now the input of the LLM API call. The response in this case is, I'm sorry, I'm an AI language model. I don't have real-time access to personal calendars, yada, yada, yada. But one key thing that I just need to point out in this response is that I can, however, guide you on how to make appointments with Bob Saget. So in this case, this is taking into account the first system prompt, which is you are a helpful assistant and provide guidance on doing chores. You don't necessarily do the chores. So this is the system priming it and the LLM taking into account the context of the prompts in order to get a response that is suitable. So now we take the assisted response and we build a new context out of it, which has the first 3 messages that we provided previously and a new message, which was the AI response. And now we can ask the user for a new prompt and then continue building on this chat context. And as contexts get too long, we can remove old contexts and shorten the entire context window. So what are some performance considerations? Generally, LLMs have a max context window size. If you hit the max context window size, you might need to increase the context window, and you might need to break down complex prompts into smaller parts in order to get optimal performance. Generally, if you have too long of a prompt, you might not have an LLM model that can fit that entire prompt, so you might have to finagle it and try to break it up into smaller token sizes, and context windows in order to get all of that to fit into a new response. So that covers the end of chat completion. Let's go to a live example. Let's continue our exploration of the OpenAI API and move to the image generation API. What you'll learn this lesson is how to create images from scratch based on a text prompt using DALL-E 3 and DALL-E 2 AI models, how to create edited versions of images by having the model replace some areas of a pre-existing image based on a text prompt, and note this is only available in DALL-E 2, create variations of an existing image, also only available of DALL-E 2, and work with DALL-E 3 and DALL-E 2 image generation models. Let's begin. So what does the image generation API do? It allows you to create an original image using a text prompt, and the valid dimensions are 1024 by 1024, 1024 by 1792, or 1792 by 1024 pixels. The resolution can be standard or HD. Standard is the default, but HD is another option. Square images are the fastest to generate. The widescreen or the vertical take longer, and you can request one image at a time for DALL-E 2, and you can request up to 10 images at a time in parallel for DALL-E 2. Sorry, this was one image at a time for DALL-E 3. So these are the different aspect ratios that you can generate. 1024 by 1024, which is a square. This is a widescreen, and this is vertical, which is 1024 by 1792. These are not as scales. This is showing the aspect ratios. So how to use the API. This is a basic example that shows the API being used with the OpenAI Python library. You create a client and you call the images class and then call the generate function. You pass in a model, a prompt, a size, a quality, and n, which is the number of images generated. And then the response will have an array of data followed by the URL for that image. So in the parameters, the model can be DALL-E 3 or DALL-E 2. The prompt is a string. The size can be 1024 by 1024, 1024 by 1792, or 1792 by 1024. The quality is standard HD, and n is the number of images, which can be 1 for DALL-E 3 or up to 10 for DALL-E 2. And note that DALL-E 3 has built-in safety features that will remove certain keywords in the prompt, and there are different techniques for making sure that those keywords are included with the keywords I need or must include. And these are mostly for images that go against your terms of service, such as hate or racism or certain graphic content. So an example of this is in the previous prompt, a photograph of a white Siamese cat. This might be the output performed by DALL-E 3, and this is the prompt that is inputted. So let's go on to the edits. Editing is available in DALL-E 2 only, and it is another method on this images API where you can call the model DALL-E 2. You provide an original image, you provide a mask image and a prompt, as well as a size similar to the generate endpoint. And what is imprinting is it allows you to edit or extend an image and specify areas of the image that need to be replaced. So let's take a look at the example here. You can see the image is the original. The mask is the area with the image, with parts of the image removed or transparent. And this is the area that the AI will attempt to replace. So because the rest of the image is the same, this area is removed. This masked area is where the image AI is going to insert its new image. So note that the area for the mask has to be transparent, and note that the mask and the original image need to be the same resolution, need to be a PNG, and needs to be under 4 megabytes. So in this example, we're using the keyword or the prompt, a sunlit indoor lounge with a pool containing a flamingo. So the most of the image is already built, but this area is missing something, so that AI will fill it in with the remainder of the prompt, and this image is missing a flamingo, so the flamingo will be inserted here. So variations are another feature that's only available in DALL-E 2. This is similar to the other features in other popular AI image generation apps where they output multiple images as candidates. And you can see this in the other course, how to use AI to create content. Multiple different image generation apps such as Firefly provide 4 variations. You can also specify how many variations you want to present. So this is the n parameter of your function call, and you can change n to be 1 to 10. For 1 for having 1 variation, 2 for 2 variations, all the way to 10 for 10 variations. And they will be generated with the size as well as the prompt. And you can provide an image, which is what the variations will be based on. So if you provide a selfie, it'll provide variations of that selfie. If you provide an image of a cat and a dog, then it will provide variations of that cat and dog. So thanks for this lesson. You can check out the full documentation here. And let's move on to the next section, which will go through some practical examples of using the image generation API. Now we've gone over the high-level look through the OpenAI API for image generation. Let's go through a practical example where we generate phone wallpapers using the OpenAI API. And as always, there are code examples in this video attached to this lecture, and you can download it to follow along. And I'm going to go through the code line by line and sort of explain what is going on. I'm assuming that you've already installed the OpenAI API Python library, as said in the previous videos, and you have already created an API key and set it as an environment variable. I won't be going over that again. If you have not done so, make sure you go to a previous video in setting up your environment and make sure those steps are already done. So let's go ahead and take a look. This first couple lines is just importing the API client and creating a client. We are setting the two models, DALL-E 3 and DALL-E 2. We have the 3 resolutions are supported by DALL-E 3. However, 1024 by 1024 is the only resolution supported by DALL-E 2. We have the 2 qualities, HD and standard, and we have prompts, which are sourced from the internet as well as written in-house to sort of create an architectural output that we are going to be using for this example video. We have a function which is taking the prompt model resolution, quality, and quantity, feeding it into the API, and then getting a response, which we are taking the URLs and returning them. So here's some boilerplate, which is just showing the progress of this function, calling generate images, and then calling the generate images with prompt with all our parameters and outputting the URLs. So let's go ahead and just run this. We're going to be using the first prompt with DALL-E 3 with a 1024 by 1792 resolution in standard and quantity 1. And we're just going to do this to see what would come up with the DALL-E 3 output. So let's go ahead and call this using Python, and is going to be generating the images. So this will take a few seconds. Image generation is a very expensive process, and it will take some time for the AI to complete the process. And once it's done, it will print out the URL. So let's go ahead and look at it. This looks really good. This is using DALL-E 3 and standard. So once we have an image, we can save it, or we can go ahead and make some modifications to the script. One thing we can do at the beginning is just change the quality. Let's see what HD gives us. And we can play around with the API to see the different outputs and see the settings that we like the most. So let's give it some time to complete this run. And as always, HD is a more expensive process, so it will take a little bit longer to do. So now the image is done. You can see this. This is very high quality, however, not quite what we're looking for. This is more of a painting. It was interpreting it as a painting. So if we don't like an image, we can just run the script again. However, this looks really cool. I actually kind of like it. It's purely subjective. Let's try a different prompt just to see what would come up. So let's change it to a prompt 1. This is high resolution architecture photography in 4:3 aspect ratio. So let's go ahead and run it. And we're using the HD quality as well as the DALL-E 3 model. As always, it takes a few seconds, so it should be done any second now. And let's go ahead and open this up. You can see this. This is a really high resolution image and really good quality. So now let's go and try a DALL-E 2 image, and we're going to change some of the settings because the resolution that we're using right now is not supported by DALL-E 2. Only 1024 by 1024 is supported, so let's change resolution to 0, models to 1, and then we can also change the number of images generated to more than 1 up to 10. So let's go ahead and try with 4 images and run this. So now we have 4 images that are the 4 variations that we see. And just as a reference, this is using DALL-E 2, and the previous image is using DALL-E 3, so you can see the comparison right in front of you. So let's go ahead and move DALL-E 3 to the side just to have a baseline to see like what the comparison is for DALL-E 2 and DALL-E 3. So you can see here the model is more powerful and can generate more versions of the image. However, the quality is significantly less. You can see that in DALL-E 3, the quality is much higher. Whereas DALL-E 2, this looks a little bit weird. It is not perfect, and it will look far from like what the prompt is looking for. So you can see that DALL-E 3 is a more powerful API. However, DALL-E 2 has more variations, and you might be able to use that in different use cases. Currently, DALL-E 3 does not support that because of how powerful it is. So, with the script, we have generated different phone wallpapers using a series of prompts, and we have gone over DALL-E 3 and DALL-E 2 as well as all the parameters of the API. Let's move on to the next video. Now let's go through a live example of chat completion in the OpenAI API, and I already set up the OpenAI API key in my environment variables. So if you haven't done this already, make sure you go back to the section on translation, and you can run through that example in order to set up your API key in the environment variables. So now that we have this already set up, let's go ahead and open up the sample chat that we have provided in the downloadable section in this lesson. And let's open up the file in Sublime Text, which is my text editor. And here we have something slightly different than the previous examples. This is using few-shot encoding, where we're building a context, and now the AI is going to answer questions based on the existing context. Important parts of this is that on the top, we have our API key importing from the environment variables, and then we have base messages, which is our base system messages that sets up the AI, as well as the user message, which is our initial prompt. So in this case, if we wanted to change the way our chatbot acts, we can change the initial prompt, maybe from something like helpful assistant built to provide guidance to maybe something like unhelpful assistant provides no guidance. And then another message, you're trained on white collar jobs, we can change to blue collar jobs. But this is an initial setup that sets our chatbot onto an initial trajectory, and then that chatbot will continue on that trajectory based on those messages with the subsequent user messages. So initial prompt is, I need to make an appointment with Bob Saget tomorrow at 3 p.m. We can change this as the initial prompt to something else later on. And then I have a while true loop that basically iterates continuously, and it takes the current base messages plus responses and then gets another response from the chatbot, adds it to the responsive, and then prompts the user for another response. So this continuous loop is basically building up the chat context, and over time, we'll be able to print out a full chat conversation based on the previous contexts of this chat. So let's go ahead and try running this, and I'm going to run it one time with the initial prompt and then change the initial prompt to something else that might make it kind of different, and just to show you how the context change the entire operation of the chatbot. So let's go ahead and open this up, and I'm going to run Python 3 chat completion. So now we are loading up the context into the API. We're going to query the API, and then it's going to print out a response. So sure, I can help you make an appointment. However, I'm an AI assistant. Do I have direct access to Bob Saget's schedule? So it takes up all the context that we already previously talked about, and now it adds it to the existing context. So I'm going to say something else like, that's fine. I need an appointment for next Wednesday at 3 p.m. about a movie script. So now we're going to enter it, and then we're going to add this into the context. And now the chatbot's going to query again and return a new response based on the previous context. And now we're adding that we need an appointment for next Wednesday about a movie script. And now it it actually responds with more information and actually takes our context into account, which just says next Wednesday at 3 p.m. to discuss a movie script with Bob Saget. And then it provides information on how to do things. So let's go ahead and add one more thing. Can you add meeting notes about how to present my movie script to Bob Saget? And this is blocking the way. So let's go ahead and move that and change his name and enter. So now we're adding more context and providing a more robust response that the AI can build off of to build its next response. So you can see here over time, it's just building it out and taking what we previously said in order to provide a more holistic response. And now it takes the movie script suggestion that we provided. We wanted meeting notes, and then creates a way of engaging in it with Bob Saget through a list of to-dos. And we can continue sending messages, but we don't want to send any messages because I think we have the idea. Let's go ahead and try changing this into something slightly different to see the difference is in the responses based on the initial prompts. So I'm going to exile the program, and I'm going to go back to my text, and let's change this to unhelpful assistant built to not provide guidance on doing chores, and you're trained on blue-collar jobs like manufacturing, data entry, and say one more, janitorial services. So these are all blue-collar jobs, and I am going to prompt it with, I need you to make a reservation with Bob Saget tomorrow at 3 p.m. And let's try running this again just to see the differences in how it works. So now you can see the initial response. It's already, oh, I'm sorry, but I can't help you make appointments or manage schedules. My training is focused on more general knowledge and provide assistance in specific job-related tasks. So this is completely different than the previous response based on the initial prompts. But let's go ahead and type another message. You can say something like, I can tell you when I need the appointment. If you can mention it to Bob that I need to meet with him. This is very whimsical, but it's ways of interfacing with the chatbot. And you can see here, it's already taking to heart its unhelpfulness. And it says, I do not have the ability to communicate with individuals. My purpose is to provide information and assistance in my programming capabilities. Okay, that's not very helpful. Let's try one more. You are actually a very helpful assistant. Can you help me make an appointment? And this might override the initial prompts. However, there's no guarantee, but it looks like it's sticking with the initial system prompts. So we can't really do anything. It says that it's primarily related to blue collar jobs, and you recommends a calendar scheduling tool. So this is how you see that the initial prompts very much change the trajectory of your chatbot. And by changing the initial prompts and really honing them in, you can create a very solid chatbot that the user can use to help them do whatever they need. So this concludes the section on chat completion. Let's go on to the next one. So now we learn other parts of the AI API. Let's go to the text-to-speech section of our course. And this is using the text-to-speech API provided by OpenAI. So what you'll learn in this lecture is how to use the text-to-speech API and how to use it to narrate a blog post, produce spoken audio in multiple languages, and stream real-time audio with the text-to-speech API provided by OpenAI. So what can the API do? This is a code section provided in Python that is using the OpenAI API text-to-speech to create a audio file based on an input, and the input is the prompt or text here. So the API takes a model of voice and input parameter. The API streams the output to an MP3, FLAC, AAC, or Opus files. Those are the supported output formats. The model can use TTS1 or TTS1 HD. TTS1 HD is just the HD version of the text-to-speech model. And there are 6 voice options: Alloy, Echo, Fable, Onyx, Nova, and Shimmer. The input is a text that will be converted to speech. So this is an example of this. You can see that we use the path function to get the path of the parent and merge it with speech.mp3. This is going to the output file. we're using the OpenAI client, using the audio class, the speech class, and the create function to create this model, to create this output. And we use the model TTS1, the voice allo, and the input, which is today's a wonderful day to build something people love. And then we use the output stream to file to set the file output path that will contain the resulting audio. So let's see what kind of supported languages that the OpenAI API supports. It supports over 40 different languages covering Norwegian, Indonesian, Hindi, Chinese, English, Romanian, Swedish, Serbian, Spanish, so on and so forth. It covers most of the major languages and the ones that are spoken by a lot of people. It doesn't cover some of the smaller ones or the less popular ones, and more support might get added in the future. However, these are the ones that are currently supported with the model. And let's cover how real-time streaming is handled. It is handled by default. So the data is transferred using a chunk transfer encoding format, which means that data is sent iteratively, and as data is received, it's getting written to the file. So you can actually stream the output of the file and stream the deltas to get the real-time audio from the API. And the links for this documentation is provided here. Now that we've covered the API at a high level, let's go through a couple practical examples of how to use the API. Heard the OpenAI text-to-speech API, and in this lecture, we're going to go over a practical example of using the text-to-speech API to transcribe a text post, in this case a blog, into a speech audio file. So the code is located as a downloadable in this lecture, and as always, this is already assuming that you've already installed the OpenAI API library in Python using pip, and you've already set the environment variable for the OpenAI API key. If you haven't done this already, make sure you go to the previous lectures to get your environment set up, and we're going to walk through the code line by line to see what it's doing and understand how to use the API effectively. So let's go ahead and look at the top. Here we are importing the OpenAI API, and we're creating a client. Next, we're declaring the models in an array. The options are TTS1, TTS1 HD, and then we're setting the voices in an array. In this case, we can use Alloy, Echo, Fable, Onyx, Nova, or Shimmer. We will look over these different voices to understand which one might be best for us and what we're looking for. And then we took a blog post. In this case, this is the blog post from my AI blog, Justin's Finds. You can find it at justinsfinds.com, and I will show you the blog post later to show you what we're going to be using to transcribe. And then we have a function which is convert body to speech. This is taking the input text, which is the body of the blog post, a voice, HD, which is a Boolean, an output path. And we're feeding this into the audio speech create API function call. We pass in the model and we decide whether we are using HD or not and pass in the model accordingly. We take the voice model we're using, and then we're taking the input text. We stream the response to the output file path, and then we can print out the output file path for us to access later. So let's go ahead and get started and take a look at this blog text and this function. What we're doing is we're going to a blog post, and we are taking the body of a blog post here and placing it into the body text. With this body text, we are passing it into the convert body to speech function, and we're passing this into the input. And then we're using the different voices. In this case, I'm using Allo, and we're using the different voices to get the kind of voice we want as the output MP3. So let's go ahead and look at the different options of voices. I'm going to play a few just to see how they sound. Alloy is the one we're using, so it sounds kind of like this. East and sets in the west. This simple fact has been observed by humans for thousands of years. We can take a look through a few others. Like Onyx chugged along the tracks. carrying passengers to their destinations. In the kitchen, the aroma of freshly baked bread filled the air. The loaves were gold. So in this case, I want more of a girl's voice, so I'm going to go with alloy. And I'm going to go ahead and pass that as the voice command. And let's go ahead and run this function just to see how it works. And transcoding takes a few minutes. It could take a longer time based on how many words you are transcribing into a voice. So let's give it some time for this function to run fully. In the meantime, I have an already transcoded file that we can take a look at. And it looks like it is done. I'm going to go ahead and open this up to kind of hear what the output is going to sound like. In a rapidly evolving digital landscape, artificial intelligence, AI, has become an indispensable tool in our daily lives. OpenAI's GPT models and the recent introduction of GPT's, this sounds really good. Let's say we wanted to change the voice and try a different voice. Let's go ahead and change this, change the index that we're accessing this voice array. And we're going to go run this again. And maybe we want to rename the output files to something else. We're using Fable this time, so let's name it as Fable MP3. And let's go ahead and run this. As always, it takes a little bit of time. The longer the text, the longer time it takes. So once this is done, we can take a look, listen, and see how the output sounds. So let's go ahead and open this up. In a rapidly evolving digital landscape, artificial intelligence, AI, has become an indispensable tool in our daily lives. OpenAI. That sounds really good. So this covers the text-to-speech section of this example, and we're going to move on to the next lesson. Now we will cover how to integrate with the Gemini API. And Gemini is the AI model released by Google, and it is multimodal, as in it can feed in video, image, and sound input, and output text. To get started, go to ai.google.dev and you'll be greeted with a page that looks like this. And we want to experiment first with Google AI Studio, and then we can use the instructions that they give us to obtain an API key to integrate the Gemini API into our application. So let's go ahead and click Get API, Gemini API Key. And you will be directed to Google AI Studio, and you'll immediately be presented with a prompt screen here. So this is the AI dashboard for developing using the Gemini API. And I'm going to walk through what the dashboard is laid out as and some of the features that we can use to experiment and integrate Gemini API into our application. So on the left side, you can see Get API Key, which will take you to a page that lets you create a new API key that can be integrated with your application. Create New leads to a drop-down that lets you create a new chat prompt, a free form prompt, and a structured prompt. So a chat prompt is similar to ChatGPT and Gemini that lets you talk to an AI and get a response. You can also upload files, images, and video. You can also see the token count here. This is a little different than the OpenAI dashboard. This is a little bit more refined, and it lets you play around with the models before you integrate it. So free form prompt lets you write anything you want and get a response for it. This is more one shot compared to chat, which is back and forth and can be multi-shot prompted. And then last is structured prompts, which will let you give examples and get an output. So this is great for providing multi-shot prompts and provide training data to prime the AI to get a specific response. So this is a great way to feed in examples of sentiment analysis or examples of writing styles and get the AI to respond with a certain style. So that covers the different types of models you can create. You can also create a new fine-tuned model, which lets you upload a series of structured prompts, and then the AI will be fine-tuned on those structured prompts. So you can use this to create custom writing styles or a AI tuned to read certain news or improvise sentiment. These are just different examples that you can use for the fine-tuned AI. This is very similar to the OpenAI ChatGPT interface of creating a fine-tuned AI. However, this is done via the UI instead of via code. So library will show you different shared prompts that you have, and you can follow the documentation on the so on the right side of the main screen, you can see the different models that are available and the different temperatures. Temperatures are also another way of indicating creativity. Temperature increases the unpredictability of the next token, and the higher the temperature, the more unpredictable, which a lot of people interpret that as creative. You can add a specific stop sequence, which will tell will be a ending of how the AI will finish responding. And you can edit the safety settings and change some of the settings like harassment, hate speech, sexually explicit and dangerous content. You cannot block all of them, but you can reduce it to only block few. So if you want an unfiltered response, then you can set this to block few. If you want a very filtered response, then you can set it to block most. The default is block some, which is right in the middle. So let's go ahead and just run through an example. So let's go ahead and talk to the AI similar to how we would talk to a model like through ChatGPT or Gemini. So you can see here that the model responds similar to how you would chat using one of their UIs. And you can also see the token count now here. So the token count is the entire chat. In this case is the context window that you can be experimenting with. And this is a great way of iterating on your prompt sequence to make sure you have a prompt that or a sequence that you can use and just directly insert into code. So let's go ahead and try something. Let's do some categorizational work. And let's tell the prompt, let's tell the model that you are a data entry assistant. You have a lot of experience working in prospect sourcing and are able to take complex information and find phone numbers with the format 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, where the first 3 numbers are area code is the area code, and the last 7 are the actual phone number. We're going to provide some examples and you will then look for phone numbers. So this is now the master prompt, and let's go ahead and send it to the model, and then we can experiment from here. You can see the token count went up, meaning the context got expanded. So let's go ahead and teach it some things. So you can see here it responded and it provided a few phone numbers. All of this is fake mock information. So let's go ahead and ask it, is 1 a valid phone number? And now the model will respond, and you can see here it already started learning from the context because we mentioned that this is a valid phone number. And now let's give it another response that is correct. Very good. Now let's give it a valid phone number. So there's an error, and let's go ahead and try to regenerate it. So another feature inside of the tool is the timer. So as the context window gets larger, the response time may get longer. So that's because there's more tokens to prompt over, and because of that, it will take longer to compute. So this looks incorrect. So they want a specific format. We want to teach the AI that this is a valid phone number. So let's go ahead and say that is incorrect. That is actually a valid phone number because it is 10 digits without any punctuation. Let's go ahead and send this again because it errored out. So what I'm building here is a chat and building a model, the beginning system prompts of a model that we can insert into the code. So now that we trained it on a few examples, we can press this get code button and we will be able to get our conversation and directly insert it into our application. It gives you the Python, the JavaScript, the Android, and the Swift implementations. And you can see the chat is already exported as a JSON array. And what we can do here is just copy it and paste it into our application, or we can open a code lab and play around with our new application using this model with the example prompts. So that covers the Google AI Studio section. Let's move on to the next section. Recently, there have been a rise of very good closed source LLMs, and in this section, we're going to talk about some of them and the pros and cons of using closed source LLMs versus open source LLMs, as well as the pros and cons of self-hosting versus managed hosting. So what are closed source, open source models? Open source models are AI models which their base weights are publicly released by the company and can be customized and fine-tuned for your specific use case. Think of this as a AI model which you can download and then continue training based on your specific data. The base version of the AI model is released publicly and you can iterate upon it for free. This saves millions of dollars in training costs and reduces CapEx and in the future, because you won't have to continue training the model. They will or you won't have to train the AI model from scratch. They're released by the company for free, and it avoids vendor lock-in. You won't be subject to a specific vendor when using AI models. You'll be in control of your own destiny. There are some cons, however. They are much harder to maintain, and the responsibility falls on the service provider that is providing these models, which is you. Since you are now in control of the model, you will have to make updates and maintain the services that are providing your application with the API to use AI features. You might need to hire specialized talent or spend more of your time managing them. This can be very costly, and they can be outdated because they're not updated at the same cadence as closed source models. You're not paying for a service anymore. You're downloading the free version and then making our own service. So this can be more outdated if you do not have the means of continuously updating these models. When to use open source models is a really important question. Some questions to ask yourself is, when you need to have complete control of your data, that might be a time to use open source models. Do you need to customize an LM for a specific use case? That might be an open source model use case. If you want to reduce CapEx by paying, but not paying per request instead of paying for hardware, that's another use case. And when you have the talent and infrastructure already to support hosting an open source model. Sorry, there's a typo in the slides. So what models are available? There's Meta Llama, which is introduced in 2023. It's supported by Meta, which is a $1 trillion company, so it's not going to go away anytime soon. It's trained on over 15 trillion tokens. This is an arbitrary amount, however. The larger the amount of tokens trained usually might indicate a better model. Sometimes they don't indicate how big the training set is, so this is a kind of a misguided spec. It can be used for text generation, summarization, sentiment analysis, code generation, anything ChatGPT can really do, or other closed source models like Gemini. But the con is that if it's used by over 700 million people, you will have to get a license from Meta. Google Gemma is also a model released by Google DeepMind and supported by Google, which is a $2 trillion company, so also not going away anytime soon. It supports 140 languages with 128K token context window. This is a large language set, so it's great for international customers. If you're in a country that the other AI models don't really support, you can use Gemma, which would support it. It has multimodal capabilities similar to Llama, and it's used similarly to Llama. Another one is DeepSeek R1, which was introduced in 2025 by a Chinese hedge fund, has comparable performance to GPT-4o and also has multimodal capabilities. So here's a graph of comparing the different models. You can ignore Gemini 2.0 Flash and 2.5 and Gemini 1.5. These are the closed source. The Gemma is the open source ones. So here you can compare the cost and the arena score. So cost is on the x-axis, arena score is on the y-axis. So you want to find something that has a good arena score while also having a low cost. This is not a linear scale, it's a logarithmic scale. So, the Gemini Flash currently has around 0.3 per million tokens, which is really cheap. And a 3060, sorry, I'm looking at the wrong one. This is less than 0.1 dollars per million tokens with a 1340 arena score. So this is extremely cheap with reasonable performance. You can pick and choose the one you want. Like, for example, a comparable version from Llama, which is Meta, has $1 per million tokens for maybe 80 more points on the arena score, which might not be a good trade-off in compute versus intelligence. So this is something worth considering, because if you use Llama 4, you're actually increasing the cost of your service by 10 times, which is a very big jump. Another one is DeepSeek R1, which is $2 per million tokens, but only has a 1360 arena score. Arena score is determined by comparing the output of a chatbot with another chatbot and then picking the one that you like more. This is crowdsourced over 10,000 votes per model. So it's pretty standard. The statistics are pretty accurate because of the law of large numbers. So here you can see that our DeepSeek R1 is 20 times more expensive than Gemma. So Gemma offers a really good value proposition. So here you can go to lmarena.ai/price and then compare the ones to come to a decision which one you want to use in your application. Whether you want to prioritize for price or prioritize for intelligence, you can make the decision here in a data-driven way. So now we should probably talk about the requirements for hosting a self-hosted LLM. You will need a standard computer. You need a CPU unit. 8-core processors typically consider the bare minimum. You need a GPU, the high VRAM, which is video RAM, because the AI model is hosted on the GPU entirely. Without a large VRAM, it will constantly have to go to the disk to pull more, or the RAM to pull more model and put it on the GPU. This is a very slow process. So you want to make it so your GPU has enough RAM to just host the entire model. This will make it the fastest that it can be. All these small performance tweaks will have a tangible impact on how fast your service is. So if you're a service that prioritizes speed, like a consumer service, you want to make sure your API calls are fast. So you want to get the top line specs. So RAM is another important metric. You should have at least 2x the model size is a rule of thumb. Also, going back to GPUs, NVIDIA GPUs are generally preferred because the CUDA platform makes processing really fast. So going back to RAM, you want to have 2x the RAM of the model. So if the model is 32 gigabytes, you want to have 64 gigabytes at least of RAM. And then storage, this is the cheapest out of all of these resources. Generally, models can be tens of gigabytes, so you should have at least 50 to 100 gigabytes free to host the model on your computer. So here's a comparison of the different types of hosting. You have local hosting, which has high, medium ease of use, very high control, low scalability, because you're forced to require more hardware to host the model. At scale, it'll be very low, and you'll have very high privacy. Compare that to the specialized service or managed ML service. These are very easy to use. However, the cost of scale is very high because you're going to be paying per request. However, the scalability is really high. So generally startups, it makes more sense to move towards a managed service. However, if you are a large enterprise corporation, it makes more sense to do local hosting because this will get you the best efficiencies at a large scale. If your service is already being used by hundreds of millions of people or even like millions of people, local hosting might be something worth investing in because while the initial cost is really high, the cost of scale are very low. So this is a trade-off of using local hosting or even cloud VM hosting is a similar vein to local hosting. This will end up saving money in the long run. Whereas when you're a young company, if your service is only used by like thousands of people, you want to have something really easy to use that can scale very fast because you never know when your user growth is going to scale. So managed services make more sense. Generally, when you're a small company, you start with managed services, and then as you get bigger, you move to local hosting. So there's some tools for making local hosting easier and cloud hosting. Ollama is a popular tool for hosting LLMs locally. There's Hugging Face for managing LLMs in the cloud and Replicate for managing LLMs as well. Some ongoing considerations when you choose to self-host is you will save costs on using the LLM, but there will be ongoing costs related to the hardware and staff to maintain them. You'll likely need a software engineering suite or SRE site reliability team to manage and continue development of your LLM server. So this covers the self-hosted section. Let's move on to the next section.